Okay, good morning, class, or good afternoon if you are 5th or 7th hour. You guys should be open to page 256 in your journals. So if you are not, please go ahead and do so right now. 256. We are going to look at numbers 1, 2, 3, 4, 5, and 6 together. So go ahead and get out a writing utensil. Okay. Numbers 1 and 2. First of all, identifying similar triangles. Okay, there are essentially 3 triangles in this first picture. There's this triangle right here, the triangle right next to it, and then the entire thing. Okay, I want you to name those triangles. Now, we talked about this yesterday. If you can clearly see a short side, a long side, and a hypotenuse, that's how I want you to label it. It's a little bit harder to see on some of these. You can't really tell what's shorter, HK or KJ. So in that case, if you can just name the triangle, if your letters aren't in the correct order, that's not a huge issue. Okay, so if we look at number 1, I see 3 triangles here. I see this triangle. I see this triangle next to it. And then I see the entire thing, the big triangle. Okay, so let's name those 3 triangles. Let's name the red triangle first. I'll call that triangle HKJ. HKJ. And that's going to be similar to the one next to it. Now, these sides here and here are not the same. Okay, this side right here, HK, will always match up with this side of the triangle next to it. Okay, so if we went in the order HKJ, we're going to start at J to name the second triangle and go JKI. Again, guys, if you don't have your letters in the exact right order, it's not a big deal. As long as you can name the triangle with 3 letters, you're okay. And that's going to be similar to the big triangle, which we can call IJH. And those are your 3 similar triangles. Okay. Let's look at number 2. Again, we have 3 triangles here. Let's start by naming, I don't know, this one. Okay, let's call that triangle NPM. That'll be similar to, we go to our next triangle, MPO. And then we look at our big triangle. If we did triangle NPM and MPO, then we'll look at OMN, the entire thing. And I'm running out of space, but if you can try and write it in one line, that would be best. Okay, so all those triangles are going to be similar to each other. I'll go ahead and give you a second to write that down. Okay. One more time, if those letters aren't in the exact right order, it's not a huge deal. Just as long as you can name the triangle, you're okay. 3 and 4, geometric mean. We learned a little formula yesterday. The geometric mean is always the square root of the 2 numbers multiplied together. This is how you find geometric mean. So if we're finding the geometric mean of number 3, we're going to take 2 and 6 and multiply them and take that square root. So the geometric mean is the square root of the 2 numbers multiplied together, in this case 2 and 6. What is 2 times 6? I'm hoping you all just yelled out 12, or you were totally quiet, which is fine. 12. And And this is not a perfect square if you type this in, or perfect square root. So it will give you a decimal, which means we need to break it down. We always leave our answers exact. 12 breaks up into, you could do 2 and 6, 3 and 4, whatever you want. I'm going to do 3 and 4. 4 breaks up into 2 and 2. Cross off the 4 since I broke that down. I have a pair of 2s and a single 3. So my final answer here, pair comes outside, 2, and single stays inside, 3. And there's my geometric mean. Okay. Same thing over here, 5 and 45. We're going to take the square root of 5 times 45. 5 times 45 is 225. Before I start breaking that down, I'm going to go ahead and type that in and see if I get a perfect square. So if I type in the square root of 225 on my calculator, so I am now on my calculator, which you can't see, but square root 225, I get 15. So I don't even have to break this one down. That one's a perfect number. Give you a second to copy those down if you haven't. Okay, let's look at numbers 5 and 6. Five and 6. Here's where we're going to start applying that geometric mean. Now we have two different situations here. We talked about both yesterday. In this first situation, they give us the altitude of this big triangle. Okay? When they give you the altitude like that, or the segment going through the figure, then our theorem says the altitude squared, so x squared equals the two pieces that it's intersecting multiplied together. So x squared equals 16 times the other piece, 9. So one more time, it's always the altitude, or the line going through it, squared equals the two pieces multiplied together. Okay? And now we can simplify this. And really what you're doing here is you're taking the geometric mean of 16 and 9 to find x. If we multiply 16 times 9, let me get my calculator out. We get 144. Okay? That's x squared. So how do I get rid of the square? I square root, and I get x equals 12. Okay? So anytime you have a problem where you are given the line going through it, you should be able to work it like that. Number 6, they don't give us this line. So we can't work it y squared equals 9 times 2 because we don't know that line in the middle. This one works a little bit different. They give you one of the legs of the big right triangle. Okay, that's y. That's the piece we're going to square. So they give you the big leg of the big right triangle. That's the piece we square. Now, it's not 9 times 2 that it's equal to. No, not 9 times 2. It's the side that it touches. So 9 times not 2, but times the whole thing. Okay, and how long is the whole thing? Well, if this piece is 9, and this piece is 2. 9 plus 2 is 11. okay? And then we solve. 9 times 11 is 99. Square root. When I type in the radical 99, that is not a perfect number. So I'm going to have to break this down. I can break it back up into 9 and 11. 9 breaks up into 3 and 3. Getting kind of low here. There we go. There's a pair. 11 is prime. So my pair comes outside, and my single stays inside. Okay. Give you a chance to copy all of that down. Now, I'm going to give you kind of a rhetorical situation here. I know it's not one of the problems, but everyone eyes up here. Let's pretend for a second, if I draw a different picture here. Let's pretend the y was over here. And we'll say this piece is 3. And this piece is, I don't know, 6, okay? And I'm going to give this some letters too. So A, B, C, and D. Okay. Y is a leg on the big triangle ABC, right? So we put y squared first. Now, which piece is touching the blue piece? The green piece or the red piece? In other words, which piece is part of the same triangle as y? Which piece is still a part of that little triangle right there, CDB? The green or the red? Well, that would be the green. That's what's touching it. So the green number comes first, 6 times, not 3, but times the whole thing. And 6 plus 3 would be 9. So you always use first the number that's on the same triangle as the leg that you were using to get the y squared from. Okay? Okay, we don't have to finish that problem. That was just to show you. That's all I have for you for a warm-up. If you need to go back, just nicely ask the teacher to rewind the video. And your homework now is a 9.3 worksheet, or to finish up the 9.3 bookwork if you didn't do that. Have a wonderful weekend, and I will see you all on Monday.